Classification. Classification means arranging the things in a particular order is called as classification. In medical shop, medicines are arranged in a are classified in a particular order. In kirana shop also goods are arranged in a particular order so that they can take them easily. Similarly, if we classify the elements, we can study the elements with simple efforts. Okay, that is the purpose of classification. If we classify the elements, we can study the elements and their compounds with simple effort. Clear? What is the meaning of classification? Arranging the things in a particular order. Arranging the things in a particular order. In a particular order. Okay. Right. First, who classified the elements? See, first Lavoisier. Lavoisier classified the elements into two types, two categories: metals and non-metals. Metals, non-metals. But this classification was failed because it didn't include metalloids. So this is the first classification, Lavoisier classification. After Lavoisier, Dobereiner classification. Dobereiner classified the elements as triads. He classified the elements as triads. What is a triad? Triad is a group of three elements. Okay. Dobereiner classified the elements as triads. Once look at this. Let us take a basket. In that so many elements are present, like lithium, sodium, potassium, calcium, strontium, barium, chlorine, bromine, iodine, like that. Okay. This basket is having so many elements. How he classified? See, he took three elements: lithium, sodium, potassium, and he called it as a triad. Why? Because it contains three elements. Triad is a group of three elements. Again, he took another three elements: calcium, strontium, and barium. Calcium, strontium, barium. This is one type of classification. Okay. He took three elements and named them as a triads. One triad, second triad, like that. Dobereiner triad. Dobereiner classified the elements as triads, group of three elements. Similarly, chlorine, bromine, iodine. This is another triad. Okay, all these are examples of triads. Right. Once look at this first triad. In first triad, if you take atomic weights, lithium 7, sodium 23, this is 39. Atomic weights. Add the atomic weights of last two elements and take average 39 plus 7 by 2. Take average 46 by 2, that is equal to 23. 23 is the atomic weight of middle element. In each triad, the average of the atomic weights of last two elements is the atomic weight of the middle element. Average of the atomic weights of last two elements is the atomic weight of middle element. This is the principle in the triad. Okay, it is also failed. Okay, because in some triads this principle is violated. Clear? These are earlier classifications only, not that much important. We can go fastly. Clear? Right. Newland's law of octaves. Newland's law of octaves. Newland's law of octaves. Law of octaves. is given by Newland scientist. What is the Newland's law of octaves? See, Newland arranged the elements in such a way that every eighth element is having similar property to that of a first element. Every eighth element is having similar property to that of first element. For example, see, hydrogen, helium is not there, hydrogen, lithium after beryllium, boron, carbon, nitrogen, oxygen. Once look at this, all of you. Let us give different color to this. 1, 2, 3, 4, 5, 6, 7. See, second element is placed beside first. Third element is placed beside second. Similarly, you tell me where we have to place eighth element in generally beside oxygen. But see where he placed the eighth element under hydrogen. See, first element and the eighth element both are placed in same group. Every eighth element, see, 1, 2, 3, 4, 5, 6, 7, 8. Here eighth element will come, no? That is placed under first element. Why? Because this one and this one are having similar properties. Every eighth element is having similar properties to that of first element. That's why eighth element is placed below hydrogen instead of placed beside oxygen. What are the similar properties? Hydrogen is a gas, fluorine also gas. Hydrogen diatomic H2, fluorine diatomic H2. Hydrogen can form H minus, fluorine also can form F minus, mono negative ions. Some similar properties are there, right? So what is Newland's law of octaves? Every eighth element is the repetition of the first element. Every eighth element is having similar property to that of first element. Clear? But you tell me this is failed after which element? After calcium, this law is not applicable. Okay? This is just a general idea, only questions won't come from this. Just basics. After calcium, law was failed. Right? Clear? Next, now Mendeleev's classification. Mendeleev's classification. Listen. Mendeleev's classification. Right. See, this is given in your schedule. Mendeleev's onwards. Okay. Right. Previous classifications are like basics only. Earlier classifications. Mendeleev classification. Mendeleev classified the elements based on the atomic weights. Mendeleev classified the elements based on the atomic weights. He arranged the elements in the increasing order of their atomic weights. First element with lower atomic weight, element with higher atomic weight, like that. Clear? Mendeleev arranged the elements in the increasing order of their atomic weights. In the increasing order of their atomic weights. Right? Very, very important point. Let us see some merits. He given vacant spaces for the elements which will be discovered in the future. Okay? And he predicted existence of some elements and named them as Eka elements and named them as Eka elements. Means he thought like this: in the future this type of element will be discovered and it is having properties like this. Just he predicted. Okay, he predicted and given the names also. He given vacant spaces in his classification. Why he given vacant spaces? In future, if any element is discovered, that element will be placed in that vacant space, right? And he also predicted existence of some element. Means this type of element may be present in the nature. Okay, someone will discover that elements. Like that, he predicted existence of some elements and named them as Eka elements also. Eka elements. Main advantage is he given vacant spaces. He predicted the existence of some elements and named them as Eka elements. See, he given vacant spaces. He given vacant spaces for the elements that would be discovered in the future. Okay. Next, he predicted existence of some elements. He predicted existence of some elements and named them as Eka elements. Eka elements. Online students, are you following, all of you? Hello. You don't write, just listen. I'll share the PDF, that's why I'm writing. Look at this. What are the last 2 points? Tell me, what are the last 2 points? He given vacant spaces and he predicted existence of some elements. See, Eka means one below. He given vacant spaces below boron. He given vacant space below aluminum. He given vacant space below silicon. Eka means one below. Okay. Below boron, below aluminum, below silicon. Eka boron means below boron. Eka aluminum means below aluminum. Eka silicon means below silicon. Eka means below. Right? Nowadays, Eka boron is called as, tell me, you know already? Eka boron. Scandium. Eka boron. Eka boron. Eka aluminium. Eka aluminium. Sorry. Eka silicon. Eka silicon. Eka boron. Scandium. These are important. Scandium. Eka aluminium. Gallium. Eka silicon. Germanium. So scandium can be write like this: scandium, gallium, germanium. Later these elements rearranged. Okay, later. Got it? Remember this. These names are very important. Okay, will come in the exam. Maybe. Right. Coming to the disadvantages or demerits. See, Mendeleev arranged the elements in the increasing order of their atomic weights. Means element with lower atomic weight, after that element with higher atomic weight, like that. Clear? Right? No doubt? Okay. Look at this. I am giving some pairs in his table, in his classification. This is just random. Tellurium and iodine. Here some elements are, just imagine some elements are present here. Okay. Look at this area. Look at this area. Observe this pair. Argon atomic weight. What? Potassium 39. Potassium 39. What is general rule? Element with a lower atomic weight. After that, element with a higher atomic weight. But look at this. Element with higher atomic weight is placed first. So this is wrong classification. Sir, now what he given? He arranged the elements in the increasing order of atomic weights. But look at this place, reverse. So this pair is called anomalous pair. Anomalous pair. Very, very important. Anomalous pair. Which of the following is anomalous pair? So how many anomalous pairs we have here? Look at this. These three are very important. You have to read. This is 58.9, 58.7 approximately. Okay. Tellurium 127. This is 126. Higher atomic weight, lower atomic weight. 58.9, 58.7. Higher. Okay. 0.1 difference is there, na? Higher, lower. But here the important point is to remember the pairs. Remember the pairs. Which of the following is anomalous pair? You no need to learn the numbers, but examples, names: argon, potassium, cobalt, nickel, and tellurium, iodine. In his entire classification, in some areas, elements with higher atomic weight are placed before the element with lower atomic weight. This is the main drawback, anomalous pairs. Anomalous pairs. And another drawback is it didn't include inert gases. It didn't include inert gases, and there is no particular place for hydrogen. These are general points. Okay. Totally he classified how many elements? Mendeleev classified 63 elements. Okay. That agar boron, agar aluminum examples, and these examples are important. Okay. Right. Let us start modern periodic table directly. Modern periodic table or long form of periodic table. Tell me. That are anomalous pairs only. What you are asking, Meenakshi? I didn't get to ask again. Anomalous means actually, if he arranged like this, potassium and argon, this is correct pair, 39, 40, increasing order, na? Increasing order, correct pair this is. But here see, reverse. First element with lower atomic weight should be placed. After that, element with higher atomic weight should be placed. But this is reverse. That's anomalous, different pair. Different pair. Okay. Right. Long form of periodic table. Long form of periodic table. Long form or extended form of periodic table. 8. In the long form of periodic table, we have 18 vertical columns, 1, 2, 3, like 18 vertical columns, and 7 horizontal rows. 7 horizontal rows. Okay, these horizontal rows are called as periods. Periods. Everyone knows about that. 7 periods and 18 groups, right? And left hand side portion, extreme left, contains highly reactive metals and called as S block elements. This is information based. Some theoretical questions will come. Left hand side portion contains highly reactive metals. Right hand side contains non-metals, mostly non-metals, and some metallites also present, that is P black. This part is P black. This is S black and P black. Highly reactive metals are present in left hand side portion and included in S black. Non-metals and some metallites also placed in the right hand side portion and placed in P black are called as P black. And the middle portion is called as, tell me, D black. This is D black. See what I mentioned here, highly reactive metals, and these are non-metals, right? Metals and non-metals. See, move in this direction. Okay, metallic property is converting into non-metallic. You started at metallic property and you reached non-metallic property, right? One property is changing or not? Completely changing. Change means transition. Another word for change is transition. That change is taking place through which elements? D black elements. So D black elements are also called as transition elements, because one property is completely changing through D black elements. The change is taking place through D black elements. So D black elements are also called as transition elements. Transition elements. Okay, and at the bottom of the periodic table is F block elements are included. F block. 4F series, 5F series. 4F series elements are called as, what is the name of 4F series? Lanthanides. And 5F series elements are called as actinides. Lanthanides and actinides. Let us take first element and last element. Starting element of lanthanides, cerium-2, lutetium. Thorium-2, lawrencium. You have to remember the ranges with atomic numbers, I'll tell you. Okay. Right, now coming to the another important naming. 1, 2, 3, 4, these are normal numbers, and we use Roman numbers also. Roman numbers also very, very important. One A, this is 1A, first A group, second A group, 1A and 2A, third A, fourth A, fifth A. Third A group is here, third B group, fourth B group, sorry, I only said wrong. Third A, okay? A continuation here. Third A, fourth A, fifth A, sixth A, seventh A group and zero group. Group numbers. Third A, fourth A, fifth A, Roman numbers. B. 1B are third B, next 4B, 5B, 6B, 7B, and these three groups are called as eighth group. Okay, 8, 9, 10 are called as eighth group elements. And 1B and 2B, 2B group elements are important. Zinc, cadmium, mercury. Important point is there. Zinc, cadmium, mercury. What is the important point about that? Which elements that are transition only na? Non-transitional. Non-transition elements belongs to which group? 2B group. Non-transition elements belongs to which group? Second B group. Can you able to see clearly, online students? This one. 1B, in 1B group. In 1B group. Copper, silver, gold. Coinage metals are present in copper, silver and gold. That is the importance. Right? Okay. Next. Observe 3B. Observe 3B. Very, very important. Why I given this classification, I will tell you. Observe third B group elements. Which group elements contains maximum number of elements in the periodic table? Third B group elements. Third B group elements. Are how? 1, 2, 3, 4 only na? But see, lanthanides will continue. Lanthanide and here actinide. Continuation. Right? Very, very, very important point. Lanthanides belongs to which group? Third B group. Can you able to see this side? Is it visible only? No, online students, all of you. Hello. The one is responding. Lanthanide belongs to which group? Third B group. Third B group. Third B group. Actinides belongs to which group? Third B group only. So remember, lanthanide belongs to third B group. Actinides belongs to next, lanthanide belongs to which period? Sixth period. Actinides belongs to seventh period. Very, very, very important. Right? And you tell me the range of lanthanides. Cerium atomic number is cerium 58 to lutetium 71. These numbers are very, very important. 58 to 71. Thorium 90 to 103. 90 to 103. Very, very, very important. Now see, I'll tell you. If you get the atomic number between this range, within this range, for example, 58 after 59, 60, like how you tell me, 61 element belongs to which group, which period? 61 means this range only, na? Means lanthanide only. Lanthanide belongs to third B group and sixth period. Over. Very easy. The element with atomic number 62, 63 belongs to, see, this is lanthanide. You will prepare this. Okay, you will remember the range. Based on that, you can guess the element group number and period number easily. So if you get any F black element, you can identify its group number, period number easily. Right? Okay. See what I am saying. For example, I am giving one atomic number. Let us say some 64 atomic number. 64. Okay, 64. Say the element group number and period number. That is the question. Okay, what is the group number and period number of the element with atomic number 64? 64. 64 is present in between this range only, na? Right? Means belongs to lanthanides. Lanthanides, La means lanthanum, lanthanide. Lanthanide belongs to which group? Third B group. Which period? Sixth period. Got it? Online students. Others are not responding. Hello. Are you there? Other girls, everyone. Clear? We will discuss about each and every group clearly. Right. But basic idea. How many periods? How many groups? 18 groups. At present, how many elements are present? 118. Right. First period, rare earth elements, inert gases, I think. Okay, we will do that also. Once you see in the first period how many elements are present, tell me. 1, 2. First period contains, so first period is called as a very short period. In second period, count 1, 2, 3, 4, 5, 6, 7. Or what happened? Something missed here. Correct. 8 elements. Second period contains 8 elements. So short period, very short. Third one, 1, 2, 3, 4, 5, 6, 7. Same. Fourth period, tell me. Fourth period, 2, 8, 8, 18, 32. Okay, right. 2, 8, 8, 18, 32. First period contains number of elements 2 elements. So very short period. Write fastly. Second period 8, short period. Third also 8. Fourth and fifth, I'm writing directly. Fourth and fifth, 18. Long period, right? Sixth and seventh. At present, seventh also completely filled. So longest period. Very short, long, longest period. Okay, right. Coming to the classification of elements into blocks. So in blocks, you will learn most of the information regarding the groups. Okay, classification into blocks. Are you comfortable, online students? All of you. This is revision, right? So little bit fast and moreover basic chapter only, na? Memory based only. You have to read. We have PDF also. I'll send this one also and my original copy also. You can go through it. If you feel this PDF is comfortable, you can follow this. Otherwise, take the Xerox. I prepared one PDF in detail. Classification into blocks. Left hand side, random diagram I am giving to you. Left hand side, which block is present? S block. Everyone knows about that S block, P block, D block, and F block elements. Right. S block element contains reactive metals. These are non-metals. Here also metals. Here also metals. Radioactive metals. Okay, general information. What is the difference between them? Metals only. These are highly reactive. Highly reactive metals are present in S block. Non-metals, reactive metals and radioactive metals are present in the F block. Right. In S block, 2 groups were included. First A group and second A group. This is very important. If anyone didn't know about the list, you will face difficult in the chemical bonding chapter. Clear? So by heart the group list. Actually this is not a basics or fundamental information, useful for the chemical bonding also. Let us start the groups. S block. S block elements general electronic configuration. I already given the properties. These are metals, highly reactive metals, right? So general electronic configuration. General electronic configuration of S block elements. NS1, 2. NS1, 2. These this block include two groups. First A, alkali metals. This list you have to learn the same sequence: hydrogen, lithium, sodium, potassium, rubidium and cesium. If you don't learn this, you will face difficult in the chemical bonding chapter, because to predict ionic nature, covalent nature, okay, you need this idea. And moreover, in this lesson only, very important periodic trends we have. What are periodic trends? Atomic radius, ionization energy, electron affinity, metallic nature. So you should have idea about this. So learn the group list. Of course most of you know, right? Now you tell me, lithium after sodium, sodium after potassium after, like that. Lithium, sodium, potassium, rubidium. This is very important information. Clear? Right. And what is another name for first A group elements? First A group elements other name is alkali metals. Alkali metals. In S block we have two groups, 1A and 2A. And second A group another name is alkaline earth metals. Right. What are the elements? Beryllium, magnesium, calcium, strontium, barium and radium. Generally we do not discuss about radioactive elements. That's why I'm not writing radioactive element. Okay. That second A group. So sizes comparison is very important. Beryllium after magnesium after calcium, like that. Okay. That is about S block elements. S block elements are highly reactive elements, good reducing agents. S block elements are good reducing agents in the periodic table. Good reducing agent. Reducing agent means the one which gives electrons easily. The one which gives electrons easily is called as a reducing agent. These metals or elements give electrons easily. Sodium gives electrons easily. Magnesium gives electrons easily. Right? Okay. Next, P block. Don't neglect these group numbers, all of you. If you know these elements list, you can understand next topic. Tomorrow's class depends on this information. Okay? Right. P block elements. P block elements, general electronic configuration. Say general electronic configuration. NS2 NP126. NS2 NP126. Why we wrote NS2 NP126? What is the meaning of NS2 NP126? What is the meaning? Take boron families. Boron configuration 1s2, 2s2, 2p1. Boron, carbon 1s2, 2s2, 2p2. Dash. Neon 1s2, 2s2, 2p6. 1 to 6. Okay. Clear? NS2, 2s2, 2s2, 2s2. This is common. So 1 to 6, that is the meaning. Okay. First group, third A group. Third A group also called as boron family. If you learn this list, next topic will be very easy to you. All of you by heart the list today only. Third A group elements: boron, aluminium, gallium, indium, thallium. Right. So can I give directly? Boron, 14th group, 4th A group. What is another name for 4th A group? Carbon family. carbon, silicon, germanium, tin, lead. Germanium, tin, lead. See, you started your preparation for final year, especially second year students. If you fail to learn these, that gap will continue until your NEET exam. So this is the best opportunity. Your college program is very good and wonderful program, Chaitanya's program, because in other colleges revision not started, syllabus only not our, other than Narayana, Chaitanya you only, but other colleges like not named. So we are very lucky you started your revision in advance. So utilize this revision program all of you. Fifth year group also called as nitrogen family. Why we are calling nitrogen family? Because nitrogen is the starting number. Nitrogen is the starting number. Another name for fifth year group, mycogens or pnictogens. Mycogens or pnictogens. Nitrogen, phosphorus, arsenic, antimony, bismuth. Next, 6A. Oxygen family. Oxygen family are also called as chalcogens. Which of the following is a chalcogen? Oxygen, sulfur, selenium, tellurium, and polonium. If you don't know the symbols, names, Google it. Okay. If I write, it will take time. Chalcogens: oxygen, sulfur, selenium, tellurium, polonium. Polonium is a radioactive element, but we will discuss some properties of polonium. Seventh year group is very, very easy. Tell me, what is the common name? Halogens. Fluorine, bromine, iodine, and astatine. And last one, noble gases. Here I'll give you one important information. Noble gases are zero gases, zero group elements. Okay, zero group are inert gases. All are same only, inert gases. My suggestion is to learn the atomic numbers of noble gases without fail. What are the noble gases? Helium, neon, argon, krypton, xenon, radon. Learn atomic numbers without fail. Helium 2, neon 10, argon 18, krypton 36, xenon 54, radon 86. Learn without fail, because in second year complex compounds we use these numbers. Okay, we have questions also in this lesson only, right? What is the indication of your revision program successfully? Will you complete this revision program or not? One small test to you. If you are able to learn all this by tomorrow, then. Otherwise, started destroying. Okay. P block. About P block. P block includes metals and metalloids also. Right. Next, D block. D block. What is another name of D block elements? Transition elements. Transition elements are D block elements. Transition elements or D block elements are classified into, see, take the mid portion. Take mid portion. I already given about this. Okay, group numbers, etc. D block elements are classified into how many series? 4 series. 3D series, 4D series, 5D series, 6D series. D block elements are classified into 4 series. Right. And we forgot about general electronic configuration. General electronic configuration N-1 D 1 to 10 NS 1 to 2. General electronic configuration. Right. What is the starting element of 3D series? Scandium. Say online students, scandium to zinc. yttrium to cadmium, lanthanum to mercury, actinium to Cn, copernicium. Atomic number, scandium atomic number 21, 21 to 30. Yttrium 39 to cadmium 48, 48. Lanthanum 57, 57 to 80. Actinium 89 to Cn 112. Why I am giving the numbers? If our fate is bad, we will get one element and its atomic number. Identify which series, to which series it belongs. Okay. And in D block you will learn about configurations, including configurations. Yttrium after which element will come? Yttrium after yttrium, zirconium, niobium, molybdenum. Molybdenum after technetium, ruthenium, rhodium, palladium, silver, cadmium. You learned about this in the D block elements. Right. Is there any special definition for transition element? Is there any special definition for transition element? Any special definition? Yes. Unpaired. See, scandium, you know, next element scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Right? So I'm not writing that. Let us write the definition of transition element. Before writing the definition, I'll give you some elements. What is iron configuration? Shortcut argon 4s2 3d6. In d orbital, some other electrons can be filled or not. So this is incompletely filled. What about copper? Copper plus argon. Say copper plus configuration argon. Sorry, take plus 2. Sorry. 4s0 3d 9. Incompletely filled D. D10 means completely filled. Some other manganese, argon 4s2 3d5. Right. Now see this zinc configuration argon 4s2 3d10. 4s2 3d10. Take its oxidation state also. Normal atomic state, oxidation state, highest oxidation state, Zn plus 2. Argon 4s0 3d10. Now observe the difference. Zinc is having completely filled d orbitals. There is no unpaired electron in its atomic state, and it's in higher oxidation state, D10. Zinc is having completely filled d orbitals. But what about these three? These are having incompletely filled d orbitals. So transition element means, how can we define this? Transition element. The elements having incompletely filled d orbitals in their normal atomic state or in their higher oxidation states. Elements with incompletely filled d orbitals in the normal state or in their higher oxidation states are called as transition elements. And what about this? Non-transition elements. Non-transition elements. How to define non-transition elements? The elements with completely filled d orbitals, D10, completely filled. Completely filled d orbitals. Okay. These are incompletely filled. And see, all of you, I'll try to give important points, exceptional points compared to your normal class, okay? Otherwise you won't come, so don't miss the revision classes. Some students will think like the revision only I can manage. intentionally I'll come with a very important points because today I gathered 10 previous year your seniors papers, right? So many exceptional questions are there. Okay, so this is up to today's class basic idea only. All of you learn the elements list. Tomorrow we will mostly finish periodic table. Okay, right? Any doubts, online students? Okay, see you tomorrow. I'll send the PDF, revise the PDF, this one and regular PDF also, but start preparation seriously. Feel that you are starting your preparation for your final NEET. Okay, all the best for all of you.